All right. So Math 9 here, this is number 8 on section 8.3, circle geometry. So this says, draw and label a diagram to illustrate the measure A, the measure of the central angle in a circle is equal to twice the measure of an inscribed angle subtended by the same arc. Okay, so that's one of the main properties that we learned. So to draw and label a diagram from those words, what I want you to do is I want you to show me that you know what those words mean, what that sentence means. Okay? So you need to know what a central angle is. You need to know what an inscribed angle is. You need to know what a circle is. Okay? And you need to be able to show me graphically or show me pictorially what this property says. So we have a center and we're going to have a central angle. So you draw two radii anywhere right there. And then we're going to have an inscribed angle. So that's going to be an angle that is going to have the vertex on the circle somewhere. So it can be anywhere there. And you sketch it like this. And it has to go to the same points that the central angle ends up in, right? And you would do a better job of this, of drawing a better circle and better lines with a ruler, okay? Tough for me on my tablet to do that. But you should draw straight lines here whenever you can. Because later in the assignment, it's going to ask you to draw a very accurate diagram. You're going to need a protractor. You'll need to make a good circle somehow. If you're going to trace something, that's fine. But a compass, maybe you haven't used a compass before. But in order to construct these properly, you're going to need a ruler and a compass and a protractor. So that's why I mentioned earlier you need your geometry sets, okay, to do this properly. So bring those so you know how to use them. All right, so again, you draw this to the best of your ability with the ruler and everything like that. And so you're going to label this somehow. You're going to label that this angle is twice as big as this one in here, right? So if you label this x, this would be 2x. Or theta, remember the little kind of the O with the line in the middle? That's the Greek letter theta. That's a symbol that's used a lot in math to represent an angle measure. Have you guys seen that before? Has that been in your textbook yet? So it's this one right here, theta. 2 theta. Have you ever seen this before? Anyone ever seen it before? No, a lot of blank stares. Okay, let me zoom in on this. So this is good for high school. You'll be using this Greek letter theta, T-H-E-T-A. That is the symbol that is designated for angle measure. And we're going to be using this a lot. Okay, so you may as well just kind of get used to what that looks like there now. So you would somehow identify that this angle and this angle are in a 1-to-2 relationship. This is the best way to do it, I think. Right? Okay. Now, if you used a given number like, 30 and 60 or something like that, or, probably not a good idea. Use a variable so that it shows it's a 1-to-2 relationship. Okay? The inscribed angles subtended by the same arc of a circle are equal. Okay? So how would you draw this? The inscribed angles subtended by the same arc of a circle are equal. So we've got the central angle subtended. How do we do B? Can someone describe that to me while I draw my awful circle here?
Do the thing that makes it look like a bow tie, where it's like goes like.
Oh, okay, okay. So draw the thing that makes it look like a bow tie.
Yeah.
Okay, let's see. So we've got one inscribed angle here, let's say. Oh, that's so bad. This is going to be tough to draw here. Okay, so let's say this one. Okay, that's an inscribed angle X right here. And then another one, any other inscribed angle would have the vertex on the circle somewhere, and it has to subtend the same arc. So we have no central angles involved here. But yeah, it looks kind of like a bow tie. And this would be X degrees as well. I like it. Yes, the bow tie picture. Okay. All right. Now, if you were to draw this carefully with a compass, and this is what the compass looks like, right? I don't know if you guys know what I'm talking about here, but the compass kind of looks like this. Okay, with a little, sometimes you have a little pencil in there. The old school ones had the little pencil in there. Okay. And then, attached to this arm, and then there's this, the stabby thing. Yeah, the stabby thing. So then you have like, you know, that, wow, okay, that's going bad. And then you put your fingers on here and you twist it around, right? So it kind of makes a circle on the paper. Right? That's a compass. That's a compass. Okay? It's not like the thing that you use to like find out where north is. It's not that one. But you stick this, and obviously this, you'd make a mark on your paper, the center of the circle, and then you'd open this up and you just carefully spin it around on a bit of an angle, so you drag it around, and then it will make a perfect circle. That's a compass. The protractor, right? This is the protractor. It's the half circle one like this, and you'll have a line all the way across the bottom here. You'll have 90 degrees, kind of right here. And then you'll have, 10, 20, 30, 40, 50, 60, 70, 80, 90, and so on. Blah, 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 blah. All the way to 180. So then what you do there, right, is you put your vertex here and your initial segment along the 0, and then you count up this way or you count up this way, whichever way it's oriented. And then, if you wanted 60 degrees, you go 10, 20, 30, 40, 50, 60 and put a little mark there. You'd pull your protractor away, and then you'd connect this point with this mark, and then you've got 60 degrees, let's say. Okay? That's a protractor. A ruler, for those of you that don't know, there you go. That's a ruler. It's straight and it's got numbers on it. Okay, all right, I don't have to go with that one. But, so you would use your compass to draw the circle, okay? Then you would use your ruler to draw the two inscribed angles coming from the same point. Then, you would use your protractor to measure these angles to confirm that they are the same. All right? And like I said, you're going to have to do that a little bit later. Okay, moving on. Not to that one, did that one yesterday. Here we go, number 11. Okay, this looks really confusing. Wow. Wow, this looks tricky. Let's see what 11 says. Point O is the center of each circle. Okay, so here's 11A. Label each vertex. Determine each value of x degrees and y degrees. Which circle properties does each question illustrate? Okay. Okay. So x degree, y degree. All right. So we look carefully at this circle here. Let's make this just a bit bigger. You can see that in the back. Okay, we know that this is 80. Always look at what you're given in the question and go from there. That's usually the best idea. So if that's going to be 80 right there, that's a central angle, right? That's a central angle. So what do you know, because this is 80, what do you know about one of the other unknown angles? What property do you see there, and what do you know? Go ahead and shout it out if you know.
It's always a 90.
Okay, I heard something about a 90.
It looks like.
Okay, it looks like a 90. What are you talking about? This here?
No.
Okay, good. Let me just pause for a second. That's not what you're saying, but just for anyone else that's thinking, oh, this looks like a 90. I think that's 90. Let's see. Yeah, that's 90. Let's make it 90. You can't do that. Okay, you can't do that because you can't just say, oh, that looks like it's 90, because these won't be to scale, right? The angles won't be exact. You can't just throw your protractor on there and measure it and get the answers all the time. Sometimes they're pretty close. But you have to use logic. You have to use the properties that we've been using to determine, okay, so this law or this theorem, right, this property states, so now I know that this is true. That's what you're looking at. Don't look at it and say, oh, x, this looks like, that's 40. Yeah, that's 40 degrees right there, no problem. And yeah, don't do that. So we've got a central angle. I heard somebody else say it. Something about x. You can get x here pretty easily. So why can we get x? What's the relationship there? Ah, thank you. The same arc was mentioned. Yes, 80 degrees right here. Look at this arc right here. That's the portion of the circle that it encompasses. And if we look carefully over here, it's going to be a different color. At x, this is an inscribed angle that subtends the exact same arc. So then that means that x is what? Or angle x, let's say, is 40 degrees. Yes. Okay. So inscribed angles are half central angles. Okay. And you can kind of abbreviate the theorem. I get it. All right. So which circle properties? Awesome. Now, how do I get y? Y would be the same as x, right? Okay, so why would y be the same as x?
And those triangles are the same
Okay, so, okay, let me help you.
Those lines.
This chord and this chord are identical, meaning making this triangle an isosceles triangle.
Yeah, that was the word.
Yeah, that's the word you're looking for. Okay, so you're on it, and in, you know what, in grade 9, this is where we have to start working on our math literacy. Honestly, we have to start using these words a little bit more often in class. So I'm going to try and use the proper words, you know, as much as I can. So I want you guys to start thinking and saying these words as well, as best you can. So this is good. You knew the right answer. Now I'm just trying to make that transition to having you kind of understand why. So that's perfect. So these are the same length. That makes this an isosceles triangle. The angles opposite of equal sides in an isosceles triangle are themselves equal. So if you have an angle that is opposite this side, that means it's going to be the same angle that's opposite the same length side. So y, excuse me, come on now, angle y is also 40 degrees, okay? And you can say property of isosceles, isosceles triangles, okay? So that's good enough. Little bit of a hint there as I know what you're thinking. Isosceles, probably one of the strangest words in math. I always have to think, is it ISC or is it ISO? ISC, isosceles. That's the way I used to say it when I was learning that word, isosceles. Okay, let's move on to 11b. 11b now. So, O is the center. I clearly have a diameter here, don't I? I clearly have a diameter here. What does that tell me about any of the other parts of this diagram here? And anyone guess? Sorry? Are they all equal? What do you mean all? Are the angles x and y equal? Are all? Well, okay. So again, kind of looks like maybe it could. From this vantage point, it doesn't look like they're all 90, so they're not all equal. And
would like x and y be the same?
would x and y be the same? Okay, good question. We can't assume that. No. If these two sides were the same as these two sides, then maybe we could, maybe, but they definitely not now. So what we have to do is we have to understand that this is like a central angle. Remember, this is like a big, huge central angle here. And you can think of this as the central angle of 180. Okay, a diameter is like a central angle that is 180 degrees, which means that any inscribed angle subtending the same arc, which is half the circle, this is 90. And also, this is 90, because the central angle is 180. Or this is a diameter. Okay? So if that's 90 and this is 90, now we can start to piece together what x and y are. Okay? So because this is isosceles triangle, okay, this upper one right here, that's an isosceles triangle, so that's going to be x as well. Okay? Just like we discussed from the last question. All right. So if this is 90, these two angles have to add up to 90 as well. So what is x? X plus 90 equals 180. So that's 2x equals 180 minus 90. X equals 90 divided by 2, 45 degrees. Yeah, 45 degrees. So angle x is 45 degrees. Everyone see that? Okay, this is a right triangle, and it's an isosceles right triangle. So, okay, all right. Now, can I assume that y is the same as x because it looks pretty close? No, it's a rough, that's a tough one to assume, right? You probably shouldn't do that. Now, this is 50, so that tells me, because this is 45 and this is 45, so that tells me that this triangle down here is not the same as this triangle up there. So we definitely have to do some thinking. Now, I'll do this in black here. So I have 50 degrees, I have 90 degrees, and I have one remaining. That's going to be pretty easy. So angle y equals 180 minus 50 minus 90. Yeah, that's what's left over. So 180 is the total, minus 50, minus 90. So what's that? 140 and 40 degrees. Angle y is 40 degrees. Okay. So properties of isosceles triangles for x, angles of a triangle add up to 180 for y, and also inscribed angle is half the central angle, subtending the same arc. So those are the properties that you've used in working out that question. So please show some work like I've done here. Again, explain the properties, jotting down some notes. Please show some work. I don't want to see just answers, okay? Really, ever. I'd like you to communicate some thinking there, because you don't just pull a number out of thin air, right? For anything. And it's like, oh, how can I show my work? This is obvious. Okay, well, tell me what's obvious about it. Write it down. Do you know what I mean? Show some work. So here I know that you're using the properties of triangles. Here I know that you understand what isosceles triangle is, and so on. Okay, stuff like that. All right, one more. We did a question like this last day as an example. And you guys rightly noticed that the central angles here, this one of 128, this one of 116, and this one of y, they all have to add up to what?
360.
Yeah, one full time around a circle is 360 degrees, so that's awesome. So that means that 116 plus 128 plus y has to equal 360, or y equals 360 minus the other ones, minus 128 and minus 116. Okay, you two. Nice. All right, so what do we get here? Who did 11C? What do you get here for angle y? 116. Sorry, 116. Okay, all right, yeah. So 244. Okay, yeah, 116. Good, excellent. So now that I know that, how can I find out what x is? And x, notice, is this big angle here. It's not split up there. What do I know about this situation that's not marked on the diagram? There's some marks that I can put on the diagram here. Anybody know what specific marks I'm thinking of? Okay, the little hash marks on where? Okay, so tell me to stop when I should put a hash mark on which side? Here? Okay, here? I can put one there, and then where's the other one? Where's another one?
There.
Here, and?
There.
Right here. Okay, those are all radii of the circle, right? Excellent. Now, I'm concerned with x, so I'm going to focus on this triangle right here. Okay? That isosceles triangle. So, just as in the last question, if you know what y is, 116, and you know that this is an isosceles triangle, guess what? This is x degrees as well. So, 2x plus the value of y, 116 degrees, equals 180 degrees. 2x, these two x's, and again, they're like terms, so x plus x is 2x, plus 116 equals 180. You guys okay with that? So then we'll solve this. 2x equals 180 minus 116. All right, which is what? What's that?
64.
Okay, so this is 64. X equals, you divide both sides by 2, you get x equals 32 degrees. So you have y equals 116, x equals 32. Does that check out with your work? And
No, because x is the whole thing, so you have to have one.
aha, thank you. So this is x right here. This is 32 right here. So do we need to reconsider our method, or can I use 32 to get my actual answer? Because this is not right.
But I think it has 128.
Okay, can I consider another triangle?
Yeah.
I can do the same thing to this triangle, I suppose, couldn't I?
Just add them.
So could I find this angle right here? Let's say this is z degrees. Could I find that one? Or is there a way I can find this whole angle at once?
Yeah.
What are your thoughts?
Well, because the original 116 triangle is a central triangle.
Okay, so you're noticing that this 116 is the same as this 116? Is that what you're saying?
No. Like
Oh,
the
I get
original
what you're
116
saying-
is a
wait.
central angle.
Okay, 116 is a central angle.
And then there's also the inscribed angle.
Ah.
On the other end. So it's
Okay.
half of 116.
Okay, so I like that one a lot. So what you're saying is that, let me just get to my right highlight here. So you're saying that this angle is a central angle, 116, and you've noticed that this is the arc that it subtends.
Yeah.
And actually, so there's another angle that subtends the exact same arc over here. Okay, so two ways you could do it, okay? Two ways you could do it. If you think about one triangle at a time, you have to solve the second triangle to get this full x. But you can do it all at once by noticing that this angle would be twice this x angle in here. Okay? So you could keep going here, which would be fine. You'd have to solve this angle in the 128 triangle and add them up. Or you could, and I'm going to, just for the sake of space, I'm going to erase this. This is the long way. Okay? That's the long way. It's still valid. If you choose a long way, that's no problem. Keep going. You can do it the long way. But angle x is equal to 1/2 of angle 116 because central inscribed angle relationship. So angle x is, what's that? 58 degrees. Okay, do you like that one? Are those both the correct answers now? All right. Okay, good job. Did everyone see that? I'm going to erase this marking here if I can. Come on. Uh-oh. So yeah, so notice that this x is this whole angle here, and that's the easiest way to find that. Okay, all right. So I'm gonna do 15 a little bit quick. I don't want to spend too much more time on this, but this is the last question. This was a bit of a challenging one, and I think the part of the challenge. How many of you got 15 without really looking at the back? You understood it and you got it. Okay, one person. Really? Okay. I didn't see very many of you working on 15 here before. I was giving you time. No one. Did anyone get to it? Anyone attempt it? Okay, a few more hands. Okay. All right. So let me just, because not many of you have attempted this one, let me just set it up for you. I'm not going to give you the whole answer, okay? But what this is asking is first of all, it says the measure of ACE, which is ACE, that's this right here, this angle right here, okay? Between a tangent DE, that's this tangent DE, and the diameter AC, okay, at the point of tangency is 90. So they're just explaining what you see in the diagram here, okay? We know that. This is a radius, and so that follows from what we learned the other day. The measure of ABC inscribed in a semicircle is 90. It's also 90. So ABC, these two are the same. So they're setting that up for you, noticing that relationship. A says, how does the angle between a tangent and a chord appear to be related to the inscribed angle on the opposite side of the chord? So they've highlighted this with the question mark there, okay? And that is to say, they also reworded this for us, that is, how is angle QRS, this one down here, related to QPR, this one up here? Are PRT and PQR related in a similar way? Okay, let's focus on one at a time. So, well, let me zoom back out again now. Whoops, out. So what has happened here between the two diagrams? Let's see if I can get them both on the same screen, pretty big. So it looks like we have a 90 here and a 90 here, good. It looks like this diameter has kind of shifted over to here a little bit, you see? This diameter is no longer there, it's shifted over there. And this angle has then decreased, you see that? So we have a decreased angle over here. So it would be like this. Now, what would happen if this point was actually brought over here as well? Well, this angle would decrease as well. You see? As these two pieces move, this one moves over here, this angle moves down here. So as this angle gets smaller, so does this one. All right? And if we take that even further, let's go even further now. Let's say that this AC has moved way over here. This angle, it actually gets pretty small. And what happens to this one? Well, this angle gets pretty small as well. So if you can kind of envision that in your mind, that this diameter is, here's an angle here, the diameter is moving and decreasing this angle here and also decreasing this angle at my elbow. You see? So they're both going down, and it might appear that they're going down at a similar rate. Now, this is a perfect circle in your textbook. These are straight lines in your textbook. This is an actual tangent line in your textbook. So you could take your protractor and you could measure these things. So this one is certainly something that you could use because these are circles, straight lines, tangents, they're all legit. And you could actually measure them if you want. So you would measure this angle with your protractor and this angle with your protractor and find out if they're the same. So what are you thinking right now? Do you think that, these are looking to be possibly the same? Okay, they look very similar, and it makes sense that if this gets smaller, that this one would also get smaller. All right, now this might be a little bit of a stretch, but okay, let me just redraw this. This is going to be terrible, but if this line right here, this RQ line, if this got really, really short, like really, really short, this angle would be super small, right? Would it make sense that this angle over here would also be super small? And as this got closer and closer and got smaller and smaller and smaller, would this still get smaller and smaller and smaller as well? Yeah, they would appear to move the same. They would appear to move the same. So B says, where's B? Or is that B? No, B. B says, construct and measure accurate diagrams to verify the relationships in part A. So I'm going to get you, because I don't think any of you have done this yet, plus nobody has a geometry set here. So you're going to construct two perfect circles, okay? Two circles. You're going to draw two perfect tangent lines. Be very careful to draw two tangent lines. And you're going to draw straight lines here. You're going to draw a triangle in there. And you're going to compare this angle, you're going to measure it, and this angle, you're going to measure it. Then you're going to do it differently. You're going to go from here to over here, make something obviously different. You're going to measure this angle and this angle. You're going to do that at least twice, and you're going to measure the angles exactly with a protractor. So you're going to need a compass, a ruler, and a protractor. Or you're going to need something to make a perfect circle, whether you trace something circular, you know what I mean, if you have something circular that you can trace. But that's what you're going to need, and you may need to do that at home. Okay, but I want everyone to do this one. So I want you to measure these angles once you've constructed these a lot better than I have, and see if that's true. So you can measure the ones in the book, but I want you to draw your own as well. All right? Any questions? So that's what 15 is asking you. Okay. Any questions at all about this homework assignment? Anything that I have gone over that you want to hear again, or that I haven't gone over? Any questions that I haven't gone over that you are having trouble with? All right. So there's some important stuff to learn too about theta, the symbol for an angle that you're going to see in high school lots, what a protractor is here, what a compass is, a ruler. So if you haven't got a geometry set or you don't have access to any of this stuff, you're going to need to get your hands on that. Okay? Circle geometry, that's what geometry set's for. All right? All right, so this is number 5C, and we know that we just learned this. This is the bow tie situation. So Z is 42. Why? Because they're subtended, or they're inscribed angles subtending the same arc. So Z equals 42. Now, I want to focus on these two angles right here, okay? I don't know if you guys have been told this before or would know this, but when you have any two straight lines, assume these are straight. Let's see if I can try to do this better. Okay, that's not good either. But assume that these are straight lines. That you know for sure that the angles that are opposite of the intersection point, those angles are always equal. They're always equal. Now, these two opposite ones, they might not be the same as the first pair, but they will be equal themselves. So anything that's opposite of a vertex in two straight lines, that's vertical angles or vertically opposite angles is the way I learned it back in the day. So vertically opposite angles are always equal. So that's a property too that I'm not sure is explicitly defined in this chapter. I don't remember seeing it, but I think it's assumed that you guys know this. So these two angles are the same. So guess what? If we have two triangles that have two corresponding angles that are equal to each other, then the third angle must be equal to the third angle of the other. So you have two triangles where two parts are equal. That means the third part has to be equal as well. So then y equals 27 as well. Okay? There's properties of triangles. All right, so you guys can be dismissed. You guys be dismissed. We'll see you tomorrow. Be ready for a quiz on this section.